Alright, so what I'd like you guys to do is we talk about logarithmic functions. We have just talked about exponential functions, right? And I'm going to write this exponential function just like we did last chapter, chapter 7. This is an exponential function. And why is that again? Why is that called an exponential function? Yes, because the variable, the x variable, is in the exponent position. That's why we call it an exponential function. So I want you to take a look at your calculators. It doesn't have to be this graphing one. But I want you to, okay, so here is an exponent button. Here's an exponent button. This technically is sort of like an exponent button. It's the reciprocal button, but we see some exponents here. I do want to point out that when you hit the second function, it's sort of the opposite of the operation. So if you're squaring something, the opposite operation would be to take the square root of something. So that's, you see that on the keys of your calculator. And do you guys see logarithm on your calculator anywhere? Now I see it on my calculator here, but do you see it on yours as well? Here's the log button, okay? Logarithm. And what I want you to notice is that the inverse of logarithm is this exponent. It's 10 to the power of x. So notice how those are connected. So if we had y equals 10 to the power of x, okay, as our exponential function, the logarithmic function is the inverse, okay? So the log, and it's logarithmic, but it's abbreviated log. The log function is the inverse of an exponential function with base 10. Okay? So if we have a base of 10, the inverse is the log function. So I just want to go just to your text there. Okay, so it's the inverse of the inverse. Now look over here in your text, you see the definition of a log function here. Okay, a function of the form y equals log base c x. Okay, and it's the inverse of the exponential function y equals c to the power of x. So I'm just going to flesh that out a little bit, and then I'm going to come back to this right here, because this is sort of a summary. But let me just explain a little bit more about what we're doing here. Now, inverse. Okay, if you think about inverse, do you guys remember in previous lessons what inverse, what's the other word that rhymes with inverse that helps us to remember how we determine an inverse function? Yes, reverse. Inverse means reverse. So that's something that we've talked about before. Inverse means reverse, for those of you that need the reminder. And of course, we're reversing x and y. That's how we do that. And so let me just explain to you, just something here, okay? So I'm just going to move this down a bit and keep copying that. But if we have this, okay, y equals 10 to the power of x, that's an exponential function. If we were going to find the inverse function, we would reverse the variables. So that means the x would come out of this position and the y would go into the exponent position. Okay? Now, how do we solve for y? This is the trick. I mean, you can't just divide by 10 because this isn't 10 times y, right? This is 10 to the power of y. So what's the inverse of 10 to the power of y? How do you get the y out of there? How do you reverse that? Well, that's where logarithms come in, okay? And so what we end up having here is that you can just go ahead and we'll flesh this out a little bit more, but in the inverse here, y equals log of x. Y equals the log of x. That's how you get it out of there. And again, we'll go into this a little bit more detail, but this right here and this right here are inverse functions of each other. Okay. Now let me just go and make sure that I'm using the same. Yeah, I'm using the same variables in the same positions as the textbook. So if we look here in your textbook, okay. All right. So this is when we reverse the variables, x equals c to the y, right? That's what we got. And then in order to write that with y, in order to isolate y, we use log. So this is the exponent, and this is how you express y in terms of c and x. The logarithm of x with base c. So again, we go back to our calculator, and we see that they're related, log and 10 to the power of x. Okay? So the logarithm really is, if you look over here in your book as well, you don't have to write this down, it's in your book, but let's just go through it. Logarithm is an exponent. It's actually an exponent. So y equals log of x. And the y here is really an exponent. So it's a little bit, that's not maybe the first thing that comes to your mind when you think about a logarithm. Oh, it's an exponent, like a number 2 or something. Well, it is, but it's a little bit tricky, and I'll show you how to go back and forth from this. It's not that hard. But so when y is the exponent here, y is called the logarithm to base c of x. Okay, and then one other thing here with the calculator, the log on your calculator is always base 10 because our number system is base 10, and that's called the common logarithm. So you might want to write this down, common logarithm. Okay, base 10, I'll throw that in the notes there. Actually, maybe do all this in the notes. Okay, so as you're finishing writing that up, let me just talk about what I mean. Okay. In your textbook it says this: y equals log of x base c, and the exponential function that goes along with that is x equals c to the y. Okay. But I'm also going to write down what happens when you have just your typical exponential function. Okay, so we go from here to here to here. All right, and what I want to just get at today is show you how to skip this step. Okay, it's really not that hard. So you can write this down, but I'm going to show you how to go directly from this to this. Okay. All right, so we have y equals c to the x is sort of like an example here, and y equals log to the x base c. So let's do an example like, okay, let's do log of 49 base 7 equals something. Okay, now, if you've never seen this before, this is going to look really strange, like a lot, like what? But what you can do is you can take a look at the exponential function and rewrite it as an exponential function. Okay, so really, if we want to write it the other way, what you do is you go 7 to the power of y equals 49. Okay, so our c value is here, 7. And the exponent, we said, was the y, right? So actually this would be the best to kind of look at, because y and y up there, that's where you put it. The y is the exponent, and then the 49 is sort of in the exponential equation, that's what it all equals. So the log of 49 base 7 equals something. What they're asking you is that 7 to the power of something is 49. Okay? And then, of course, we know that y is 2 here, right? Because 7 to the power of 2 is 49. Well, okay, think, what does log have to do with it? Okay, so 7 to the power of y, right? Now, if I am trying to find out y, okay, and I'm trying to go, if I'm trying to go backwards, like it's the opposite of to the power of. Okay, think about the opposite operations. Like if you add something, what's the opposite of that? Subtract. If you multiply something, the opposite is divide, right? If you square something, the opposite is square root. So if you take something to the power of something, okay, undoing that is taking the logarithm, okay? Sort of like that, you know, okay? Yeah. So let's do another example, because I think just many examples will help, okay? So if I have the log of 100 equals y. Now if I don't put a base here, this is the common logarithm, base 10. So the common logarithm, you don't really show a base there. If you don't have a base shown there, it's assumed to be 10. And so what this is saying is 10 to the power of something equals 100. Okay? So think of base, think of exponent equals this thing. So this to the power of that equals this. And so of course y is 2 here. And a lot of these, if you actually think of it as the exponential way, if you rewrite it in the exponential way, you can actually get to your answer really quick. Okay? Any questions on that so far? Okay, let's do another example that's maybe a little bit trickier. Log of root 8 base 2. What is that? Well, if we're trying to solve a logarithm, what this means is that if I take 2 to some power, I should get root 8. And so what we've just been doing last chapter is solving these exponentials, right? And so you would rewrite it as 2 to the power of y equals the square root of 8. And I can't stress enough that going back and forth between these two is really going to help you understand this and solve it. Just find out the missing value there. So 2 to some power equals root 8. Well, root 8, okay, so that's actually 8 to the 1/2, right? Talking about square root of something, that's to the root, it's to the power of 1/2. Now, remember from last chapter, what's one way to solve this? Same base, okay? So 2 to the y, 8 is actually 2 cubed. So I would rewrite that like that, which becomes 2 to the y equals 2 to the 3 over 2. And then y equals 3 over 2. We look at our calculator, and if we just explore log and 10 to the power of x, we say, let's say 10 to the power of, and let's say 4. And I hit enter. Calculator is going to tell me that 10 times 10 times 10 times 10, 4 times, is going to give me 10,000, right? The logarithm function, you can take a number like this, and then you can ask the calculator to tell you what is the exponent on 10. And so you say log of 10,000 equals, and it'll go backwards. It'll give you this number. So let's say I want to find out, okay, if I want to find out what exponent on 10 would be 5,469. Okay, now we'll think about this, right? I know 10 to the 4 is 10,000. 10 to the 3 is 1,000. So this number, I'm asking the calculator, give me an exponent, the log is an exponent, that I can apply to 10, so 10 to the power of what, gives me this number exactly. Obviously it's going to be a decimal, right? Weird number. So you ask the calculator, and that's what you get right there. So if I did 10 to the power of 3.7397 on all this decimal here, I would get 5,469. That's what that's saying.